So here in 7.2, we're going to talk a little bit more about domain. In particular, we're going to be talking about how you can figure out the domain of a function by looking at the equation. And there's really essentially two key ideas that you have to keep in mind here. One of the key ideas is that you're not allowed to divide by 0. That's an illegal thing, that you can't allow that, so that will lead you to some issues with domain. And the other issue is that you can't do square roots of a negative. So keep those two ideas in mind, and you should be pretty much on the right path to figuring out the domain for just about any function. As a starting point, if you don't have any roots, if you don't have any denominators, then your domain should be very simple. Your domain, in that situation, will be everything, all real numbers. What that means is, for this function, you can plug anything you want in. There are no limitations. Big numbers, small numbers, fractions, positive, negative, doesn't matter. Plug in anything you want. Now, saying it in words is often quite acceptable. Interval notation is quite often asked for on the computer and on tests. So interval notation would be the numbers from -infinity to infinity, which looks like that. And if you just like to use fancy terminology and notation, the symbol for the set of all real numbers is a double capital R. It's got two vertical lines in it. And you can use any of those depending on what's asked for. If the question says write it in words, you have to write it in words. If it says write it in interval notation, you have to write it in interval notation. But if you do have a denominator or if you do have a root, then there's going to be some work you have to do. Like the second function here, h. This has a denominator. And since the rule is that you cannot divide by 0, what that means is the denominator that we've got here, x squared minus x minus 6, that cannot be allowed to be 0. So what you do is you think about it backwards, you pretend it was an equation, and you solve it like you would normally solve an equation. Factor it. Break it up into two equations. Solve each one of those equations. And what you discover is that you can plug anything you want into this function except these specific two numbers. You cannot plug in 3. You cannot plug in -2. So the domain, the easiest way to say it is x is not equal to -2 or 3. And most of the time that's a perfectly acceptable answer. Every once in a while you might run into a problem that says write your answer in interval notation, but it's really awkward here to write this in interval notation. It looks like this. When you eliminate -2 and 3, you're basically separating the number line into 3 different sections. The section below -2, the section between -2 and 3, and the section bigger than 3. So you end up with 3 intervals. So you usually won't have to worry about being asked to find something like that. Usually you'll just write it as x not equal to -2 comma 3, and that will be acceptable. The other issue you've got is roots. If you have a square root, like in this case, the inside of the square root cannot be negative. So the rule here is you cannot take square root of a negative. So what that means is the stuff that's inside the square root, whatever it is, in this case it's 2 minus x, whatever's inside the square root, it has to be 0 or larger. It cannot be negative. And that's an inequality. And you solve it like you would solve any inequality. Move the 2 to the other side, divide by -1. When you divide by -1, don't forget that means you have to change the direction of the inequality. So the domain here could be written exactly like that. You could write it in inequality form, where you say x less than or equal to 2. Or in this case, it's not too bad in interval notation. In interval notation, it looks like that. So that would be acceptable as well. And then this last one here on the right, this has a combination of both issues. There's a root, which means the inside of the root cannot be negative. It's got to be bigger than or equal to 0. But it's also a denominator. And since it's a denominator, that means that the equals to 0 part, that might be okay for the root, but won't be okay for the denominator. So what you actually end up with is an inequality that looks like this. And then you're kind of stuck because that's a new type of inequality that we don't yet know how to solve. This inequality, this is a non-linear inequality. And unfortunately, you might think that you can treat it just like you would treat a quadratic equation, but a quadratic inequality and a quadratic equation are really different. We don't know how to solve this yet. We will learn that later in this class, but currently we don't yet know how to solve it. Come back to that later this semester and we'll see how to solve that sort of a thing. So the two key ideas are can't divide by 0, can't do square root of a negative. And no matter how complicated the equation is, you should be at least able to get to this stage of the equation, or inequality, just from knowing your denominator can't be 0 and you can't do a square root of a negative. Now, whether you can go to the next step depends on whether the thing you're looking at is something you know how to solve, but don't skip the first couple of steps to get you there. Now, there is one other situation where domain gets a little bit tricky, and that has to do with word problems. If you're dealing with a word problem, the equation itself might have absolutely no problems with the domain. I mean, look at this thing. Does this have a denominator? Is there any danger that we might divide by 0? No. Does it have a root? Is there any place in here where we might accidentally try to do a square root of a negative? No. And normally, what that would mean is the domain is all real numbers, but not this time. The reason it doesn't work this time is because this equation isn't just a pure equation. This is an equation that represents a real situation. There's a building, it's 400 feet tall, a penny gets dropped off of the building, and so because of that, you can't actually plug in negative numbers for t. T has to be bigger than or equal to 0. A negative value for t is before the penny was let go from the top of the building. This equation isn't going to make sense for that situation. T has to be bigger than or equal to 0, not from the equation, but from reality. Now, there's also another limitation in case you're curious. In this situation, t also has to be less than or equal to 5. Now, you're probably wondering, why does it have to be less than or equal to 5? Because at t equals 5, h comes out to be 0. Well, so what's the big deal? Well, that means the penny hits the ground. When the height is 0, that means the penny hits the ground. And the equation is going to stop working at that point. So the domain for this function, the domain here is from 0 to 5. In interval notation, that would look like this. So do not divide by 0, don't take square roots and negatives, and when you're looking at a word problem, make sure you read and think about the limitations based on reality, not just based on the equation. Here in section 7.2, there is one other little topic that we have to talk about that's a little bit related to domain, but it's kind of its own separate little topic. It's a thing called piecewise functions. And they're really complicated looking things that are not really so bad if you know how to read them. All that you're going to have to do with piecewise functions for right now is just practice plugging numbers into the function, like the 3 questions we have down at the bottom. Find the following values. Find f of negative 5, find f of 1, find f of 3. So here's how this works. the first thing you have to do is figure out where does negative 5 fit into this function. And the way you answer that is by looking at these inequalities here first. And for those inequalities, negative 5 only fits one of them. It fits the top one. It's not between negative 1 and 2. It's not bigger than 2. Negative 5 is smaller than negative 1. So first you figure out which inequality it fits. Once you know which inequality it fits, that tells you what equation you're plugging into. We are going to use the equation x plus 4, oops, I almost wrote x plus 5, x plus 4, and we're going to plug negative 5 in for x. So that's pretty easy. Comes out negative 1. Once you know what you're supposed to do, how you're supposed to read these, that you look at the inequality first to figure out which row you're in, and then you plug into the equation from that row, the actual process of plugging in will be easy. Like, let's take a look at this next one, f of 1. Where does 1 fit? 1 fits into the middle. So for this one, we're going to be plugging into 1 minus x squared. And if you plug a 1 in there, you're going to be doing 1 minus 1 squared. So let's see, 1 squared is 1, 1 minus 1, we get 0. And don't panic if you get 0. That's not a bizarre answer. That doesn't mean something's wrong. It's a number just like any other number. It's a perfectly acceptable answer. And then last one, where does 3 fit? 3 fits here, so we're going to be plugging into that. We're going to be doing 3 minus x, where we're going to plug in 3 for x, and that also comes out to be 0. Remember, with functions, you can share an output. You can have the same output more than once, and that's not a problem. So although this is its own separate little topic, and it's only a little bit related to domain, because those inequalities on the right tell you the domain, it's a fairly easy topic. You'll be pretty successful at this pretty quickly.